Welcome to Academic Dentist class. This question says two parallel plates of area 120 centimeter square, each with equal but opposite charges of 9.8 times 10 raised to power minus 7 coulombs. The electric field within the dielectric material filling the space between the plates is 4.1 times 10 raised to power 6 volts per meter. A. Find the dielectric constant of the material. B. Determine the magnitude of the charge induced on each dielectric surface. So the question is for you to write it down. Then you now see how we are solving it. This exercise in the textbook. So solutions. So the first one. So they said there that we should find the dielectric constant. So to find the dielectric constant, the easiest way to do this when electric field is given is to simply say electric field is equals to initial electric field, or you say electric field in final, yes, final electric field, yes, or electric field when there is dielectric constant is equals to initial electric field all over constant. So making case subject to the formula, you now have E naught over E, which is, in that question we are given that initial electric field is 9.2 microfarad, and that is, so 9.2 times initial electric field, yes, where is it? Okay. The electric field within the dielectric material filling the space between the plates is 4.1, the electric field itself. Then they did not give us the initial electric field. They did not give us the initial electric field, but we can actually find it. Okay, so we are not given initial electric field, but I've already gotten it to be 9.2 times 10 raised to power 6. So divide by the electric field given, which is 4.1 times 10 raised to power 6. So that K will simply be equals to 2.24. Okay. Now somebody wants to ask me, how did you find the electric field, the initial electric field? So how to do that is to simply say, so this is an alternative when you are able to find E naught. So to find E naught, how we do it is to simply say surface density, initial surface density is equals to charge over area. And in that question, we are given a charge of 9.8 times 10. I will not be going back to the question. I want to believe that how you're supposed to do this is, as I've read that question, you go back, pick the question, pick the question, then as you pick the question, you'll be looking at it to see what I'm doing. So if I know this to the charge, then the area I'm giving in the question, I'm giving the area of 120 centimeter square, and 120 centimeter square should be converted to meter because that's the SI unit. So 1.2 times 10 raised to power minus 2 is the equivalent of 120 centimeter square. So if you do this, you see that you now have that surface density is simply 8.17 times 10 raised to power minus 5 coulombs per meter square. So if you do it, because you first of all get 8.17 times 10 raised to power minus 7 plus 2. So it will now give you this. So if I've gotten this, I'll now say electric field, but initial electric field, that's the one I'm not giving because I'm giving final electric field. or yes, so initial electric field is equals to surface density initial all over permittivity of free space. If you remember from this formula, if you've been following my video, from that EA equals to Q over E naught, we said that Q from this formula now, Q can be the same thing as saying permittivity of surface density times A all over E naught. If you make E subject of the formula here, you now have, come down, this will cancel this, and remember that is the initial one we are talking about, so that is why we have this. So we can now see that E naught will be equals to, we've already gotten surface density to be 8.17 times 10 raised to the power minus 5 all over permittivity of free space is constant 8.85 times 10, yes, raised to the power minus 12. So that if you do it properly, you punch it, you see that it will give you 0.92 times 10 raised to the power 7, which is equivalent to 9.2 times 10 raised to the power 6 Newton per coulombs. So that is how we got that. So that is how we got E naught that we used. So that is to get, or you say how to get E naught. So we've gotten it. So now we need to get induced electric field, because you remember we are summarizing the whole topic. So from this question, even if they did not ask it, how to get induced or electric field induced. So remembering the formula, we now say E is equals to E naught minus E induced. So that E induced will be equals to E naught minus E, which is E induced is equals to 9.2 times 10 raised to the power minus 10 raised to the power 6 minus 4.1 times 10 raised to the power 6. So that E induced is equals to 5.1 times 10 raised to the power 6 Newton per coulombs. That is how you find your E induced. Alright, so if we've gotten this, we can actually say another, or should I say alternative method to finding K, to be sure if our K is constant. Okay, how to find K? And K is equals to ER, if you still remember, using formula for E induced. So we can now say from E induced, we've already proved all these things. Turn into 1 minus 1 over K. We have that E induced is 5.1 times, yes, times 10 raised to the power 6 equals to E initial, that is initial electric field, 9.2 times 10 raised to the power 6 into 1 minus 1 over K. So that you now have, doing LCM, you now have this to be 9.2 times 10 raised to the power 6K minus 9.2 times 10 raised to the power 6 all over K equals to 5.1 times 10 raised to the power 6 all over 1. That is taking LCM. If this come inside here, this come inside here. So that you now have 5.1 times 10 raised to the power 6k is equals to 9.2 times 10 raised to the power 6k minus 9.2 times 10 raised to the power 6. This can move over. That is collecting the k's. If you collect the k's, you will have that this will be the same as saying 5.1 times 10 raised to the power 6k minus 9.2 times 10 raised to the power 6k equals to minus 9.2 times 10 raised to the power 6. So if you do it where you see that you now have this side, if you subtract, you have 4.1 times 10 raised to the power 6k is equals to, and this is going to be minus because smaller number is subtracting big number. So minus cancel minus. You can say divide both sides by the coefficient of k to get k, so that you now have 4.1 times 10 raised to the power 6k equals to 9.2 times 10 raised to the power 6 divided by 4.1 times 10 raised to the power 6. So that k will now be equals to 2.24 times 10 raised to the power 6 minus 6. And that means this will be 10 raised to the power 0, and anything raised to the power 0 is 1. So times 2.24. So k is equals to 2.24. Simple. So this is if you want to stress yourself. But if you don't want to stress yourself, once you get this thing, that is, once you get this particular E naught, you will use this formula to get this k, because it's the same thing. So now the B part of the question. So we've gotten the A part. The A part of the question says we should find the dielectric constant of the material, and it's 2.2. So to find the magnitude of the charge induced on each dielectric surface, that's why it's important to try and remember how to use this formula, because now we can easily see that we have an equation that is from equation of, okay, so B, from equation of Q induced, charge induced, to be equals to initial charge 1 minus 1 over K. Go and watch my video, I've taught you this, so that this will now be the same thing as saying Q induced equals to Q naught minus Q naught over 1 all over K. That is, this enter here, this enter here. So if you do LCM, you see that Q induced is equals to, taking LCM, K into this Q naught minus K into this 1 Q naught. So Q induced, I can use this, I can use small letter, whichever, is now going to be equals to, K is 2.24 from the question. Then the Q naught, the initial charge we are given, if you remember, is 9.8. Look at the question, times 10 raised to the power minus 7. That's what we were given when we started. So minus 9.8 times 10 raised to the power minus 7 all over 2.24. That is K. So that Q induced will be equals to, if this times this, you get 21.95 times 10 raised to the power minus 7. Then minus 9.8 times 10 raised to the power minus 7 all over 2.24. So Q induced will be equals to If you subtract this, you get 12.15 times 10 raised to the power minus 7 all over 2.24. So if you punch this very well, you get that Q induced will be equals to 5.42 times 10 raised to the power minus 7 coulombs. There you have it.